Today I'm going to show an interesting example of the properties of water that occurs because of intermolecular forces. In my example, I show capillary action, which works with cohesion and adhesion pertaining to H2O. Cohesion is the attraction between two molecules of the same kind, and in this situation creates surface tension. Adhesion is the attraction of one molecule to a different type of molecule, and this is especially strong for water. Capillary action occurs when the adhesion to the walls is stronger than the cohesive forces between the liquid molecules. There are hydrogen bonds between water molecules because it is polar. Because the water is polar, it is attracted to other polar molecules, and the hydrogen bonds are strong enough that during this IMF example, the water stays together while in the process of capillary action. In this demonstration, I am going to show how water molecules can travel upwards on a paper towel and completely move on their own to another cup because of their intermolecular forces. So for this procedure, you need 7 clear plastic cups, water, food coloring, and paper towels. First, you add an equal amount of water into 4 of the empty cups, and then add in a few drops of food coloring into each cup. Next, you fold 6 pieces of paper towel in half, and then the opposite way once. Lastly, you place an empty cup between cups filled with water and use the paper towel as the connector between plastic cups. After a few minutes, you can easily see that the water has begun to travel up the paper towel, and you can tell because the food coloring is also traveling upwards with the water. This is interesting because even though the gravity is pulling the water molecules down, the intermolecular forces between the water and the paper towel overpowers it. After a time span of about 15 more minutes, you can see an example of adhesion because the water is traveling up the small canals of the paper towel and crawling up the sides until it reaches the next cup because it is a polar molecule and it is sticky. After about an hour, we begin to see actual water inside the other cup. What is holding this together is the cohesion of hydrogen bonds from these water molecules. Because hydrogen bonds allow the dipoles to be attracted to a neighboring molecule, the water is able to have capillary action and defy gravity. Over time of about 4 hours, the water evens out throughout the cups, and all of this was made possible by the properties of the water molecule and its intermolecular forces.